Pause the video and have a quick go at the starter question there on the board. This is a tree diagram from GCSE, and they're also included at A level. So I'm going to assume that you have done that. The solutions here are on the board. What are some things we notice on a tree diagram? First of all, when you branch off, probabilities add to 1. Here and here, here and here, and so on. If we want to find the probability of one event and then the other event, so for example, the first event is passing science and the second is passing geography, we follow the diagram. So we go this way to pass, and then we do pass again this way. The probabilities that we come into contact on our way, we multiply these together, okay? The person will fail both tests, so we do fail, then fail again, and we multiply these together. More interesting is when you have questions where things can happen in 2 different ways. So pass 1 and fail 1. It doesn't specify which subject you have to pass and which subject you have to fail. So we can talk about pass and fail, or fail and pass, and that's what they have done here. The same steps as before, we just have to add them together at the end. Why? Because they are mutually exclusive events. Passing and failing cannot happen at the same time as failing and passing, so you add them together. Tree diagrams then. Tree diagrams are very, very good for when you have events in succession. What does that mean? It means you do one thing, and then you do another thing again after that, okay? I quite like them because they're quite a visual way of thinking about things. But this idea of succession, this is quite separate to the other key terms that we've done so far. So this is just a certain situation when a particular diagram can be quite useful. There are 3 yellow and 2 green counters in a bag. I take 2 counters at random. So I take 2. This is the idea of the successive events, taking one and then taking another. Okay, so taking the first and then taking the second. Okay, the probabilities, well, if you are equally likely to pick a green or a red one, we're talking about 3/5 and 2/5 as our starting probabilities. Determine the probability that they are the same color. Well, let's call this one here yellow and green, yellow, green, yellow, green. How can we take the same color? Well, we could do yellow, yellow, and we could do green, green. So we would need to go this way and then this way again. And then we would need to add that to this way and this way. You should notice, though, that we are not replacing. So if we have yellow, yellow, 3/5 is to start with. But then because we have just removed one, there is one fewer yellow one to pick from, and there's one fewer counter in the bag. Okay, so your denominator should be 20, not 25. For green, green, it's the same idea. You have one less green one if you've already picked a green, and one less total counter. We find these ones here, we add them together, and we simplify. Okay. Yeah, I haven't done like a full tree diagram for this one, just because space is a little bit limited. But you can just sort of follow to make sure you do that. Different colors. How is different colors possible? Well, it's a bit like the pass, fail, fail, pass. So this could be yellow, green, and green, yellow. So take a moment, pause the video, just work those ones out. And remember, these are mutually exclusive, sort of different outcomes. So when you find these probabilities, add them together. So 3/5 and green should be 2/4. When you have removed a yellow, it doesn't reduce the chance of a green, but there is one fewer counter in total. And this one here, green, should be 2/5 times 3/4. These ones and added together give us 3/5. Okay, you could have, some of you may have noticed, you can only pick the same color both times or different colors. So you could have done 1 minus the same color would give you different color. If you're not comfortable with that idea, though, don't worry about it. The probability I hit a target on each shot is 0.3. I keep firing until I hit the target. So if you hit the target, you stop. What's the probability you hit it on your fifth shot? You will hit it on your fifth shot if you don't hit, don't hit, don't hit, don't hit, hit. The probability you hit is 0.3. The probability that you don't hit is everything else, is 0.7. So in other words, we want, let's say, don't hit, don't hit, don't hit, don't hit, hit. And we can multiply these together. So I'm going to say that this is 0.7 times 0.7 times 0.7 times 0.7 to the power of 4 times by 0.3. Okay. Why would you not want to do a tree diagram there? Well, you could. It's just going to become a very, very, very big diagram. So you might want to extrapolate the idea of thinking about how it happens and then multiplying the numbers. Pause the video and have a quick go at that exercise there on the board and check that you're comfortable with it. So the probability of not getting 3 tails, the easiest way to do this is find, tails, find tails, 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 which is 1/8, and then to do 1 minus that 1/8 is the easiest way, because you can either get 3 tails or you can not get 3 tails. That's everything that can happen. That's another way of thinking about it, and it should add up to 1 in total. What's the probability of getting the same outcome on your first and third flip? Well, just think about how it could happen. Heads, and then heads at the end. So it could be heads, heads, heads. But the middle one's not important. So you could also have heads, tails, heads. Tails to tails. Well, there's 2. You could do tails, heads, tails, and tails, tails, tails. So it's a half. There's 4 out of the 8 options, and these are all equally likely if it is a fair coin. Okay, so that pretty much takes you to the end of the exercise. To be honest with you, you may wish to have a go at a more challenging question there on the board. If you do, pause that one there. This one is quite challenging though. And if you've had a go at that one there, those are the answers on the board. So that takes us to the end of Chapter 5, Probability. Please make sure that you really, really understand how to handle independent and mutually exclusive events.